Hello everyone. So today we will see a very interesting application of our principles of motion in a plane. I had given you a couple of examples of motion in a plane. One first example is a projectile motion. So let us analyze all that projectile motion. You just take a ball and throw it and just see how far it falls. But the things are not as simple as they look from the surface. So there are so many things to analyze. How far does it go? How high does it rise? How much time does it take? What happens if I don't throw a ball on the ground but inside a basket? When you're playing a basketball, you throw the ball into the basket. The basket is at some distance from you and it is at some height. Now, with what speed and what angle should I throw it? Your brain does all those calculations at the background and decides the speed and the angle at which you should throw the ball. So how does all that happen? What are the equations that are involved and are solved by your brain intuitively? That all we will see. So let us first take a very simple case where you have a ball in your hand and you throw it with a speed u meters per second at an angle alpha. So this is a common terminology we will be using in this chapter. The speed we will designate, initial speed we will designate it with u, and the angle that it makes with the ground, that is with horizontal, we will designate it with alpha. This is a common terminology we will be using throughout this chapter. Now when you throw this ball, you actually hold the ball at some height from the ground, right, and then throw it. But let us assume that the ball is thrown from the ground for simplicity purposes. Then once you learn how to apply all the principles, you can actually give it some height from the ground. So let us say I am holding the ball at say 4 feet from the ground and then throw it. Then where on the ground does it fall? You can solve all those kinds of examples. But let us not bring all the variations all at once. Let us first assume simplicity that the ball is already on the ground and it is thrown from the ground with this speed and this angle. Then where does it fall? It will fall somewhere here. Now some more terminology coming in picture. The distance at which the ball falls from the throwing point is called as range, designated by R, range. Okay. The maximum height, that is the maximum height reached in the entire path of the ball from the ground, it is designated as height, capital H. Okay. Then the time for which the ball is in the air, is called as time of flight, designated by capital T. So our aim will be to find these three important things that totally define our projectile motion. This kind of a motion is called as projectile motion. So it is designated by time of flight, that is the time for which the ball stays in the air, the height, maximum height reached by the ball, and the range, that is the maximum distance covered by the ball, horizontal. Now we will start applying our principles. So the first principle of 2D motion says, I have already explained it in the last lecture, that a 2D motion should be analyzed as if they are two one-dimensional motions, right? So what are the two directions that are involved in this motion? First direction is the x direction, other direction is the y direction, right? Your ball, picture it at any point of time, when the ball is here or when the ball is here, right? It has x position and it has y position. It has x position and it has y position. Also, its velocity will have certain x component and certain y component. That is, all the motion that is happening is either in x direction or in y direction. Now throughout the motion, what is the acceleration of the ball? The acceleration is g meters per second square, that is gravity, meters per second square. The value is 9.81, but we will assume that it is 10 for simplicity purposes. So g meters per second square downward, that is in negative y direction. This is positive y direction, negative y direction is g meters per second square. Throughout the motion, the same acceleration will be in picture. Horizontally, there is no acceleration. What is the reason? Because once the ball leaves our hand, there is no force acting on the ball which can change its speed, and that is why horizontally there is no acceleration involved. So ay is g or other minus g if you assume upward as positive. So let us also give sign conventions. Upward positive, rightward positive. And the origin is at this point. So let me in fact give the sign conventions at the same point just to avoid a confusion. So your upward is positive and your rightward is positive. Okay. Now from that origin, if you start, your acceleration is ay is equal to minus g, ax is equal to nothing, 0, because there is no acceleration. Now that horizontal acceleration will come in picture only if during the flight there is some wind blowing in certain direction, let us say forward x direction or backward x direction. If the wind is blowing, then that forward or backward acceleration might come into picture, but that is for advanced level problems. So right now we have a simplistic case. Now let us begin. We are going to split it as two 1D motions, right? We are going to split it as two 1D motions. I call it there.
तिथे ay आणि ax जे काही आहे ते लिहायचं. ay is equal to minus.
ये झाले आता एक एक लिहित जाणार आहे ना सर, 2 1D. Begin it as 2 1D. So this side I will write everything about x motion, and this side I will write everything about y motion. Okay, and remember the linkage between x motion and y motion is going to be our time. That is the time of flight. That is going to be the linkage between the two, because for x motion and for y motion, that is the common parameter that will be equal for both the motions. Now there is an interesting way you can analyze this situation. Imagine that there is some screen or some wall in here, and the floor or the land is already in here. Now you have two light sources. One light source you can throw from this side, okay, like this. And imagine that the light source is linear, so if the object is here, its shadow will directly fall on this point. If the object is here, its shadow will directly fall on this point, on the wall. So you are going to analyze the motion of that shadow. Another light source, the second light source that you have, you keep it here vertically at the top. It is also a linear light source, and that is why when the object is here, its shadow because of this light source will fall in here. Here, when the object is here, its shadow will fall here, and likewise. Okay. Now try to imagine this situation and analyze the motion of those shadows. What will happen to the horizontally moving shadow? As the object moves, it will move in this horizontal direction and it will finally stop here. What will happen to the vertically moving shadow? It will first rise and then fall down and will stop here. So it is as good as this is a motion of a ball that is thrown vertically up, and this is a motion of a ball which is rolling on the floor. Okay. Now once we do that, x motion, we will write our 5 parameters: s, u, v, a and t. Here also we will write our 5 parameters: s, u, v, a, t. Remember that these parameters are only about the horizontal motion. These are only about the vertical motion. So let us plug in parameters. What is my s? Now this is y motion. So how much is my s? To know all these parameters, you should first decide what is your initial position, what is your final position. And that is the reason I told you to imagine about the shadows. Now for horizontal shadow, that is x motion, this is the initial point, this is the final. For vertical motion, that is y motion, this is the initial point. The shadow moves all the way up and back down at the same point. So the final point is also the same. And that is why the displacement in vertical direction, meaning change in the position in vertical direction, is 0. How do I analyze it? The ball started from here. Where was its vertical position? It was at y is equal to 0. The ball ended here. What is its vertical position? It's again 0. So there is no change in the position. It was 0, it is 0. And that is why vertical displacement, that is y motion's displacement, is 0. Now, x motion's displacement, it is this much, but what have we designated it as? R, that is our range, right? Now, u, this u will stand for x motion's u, that is horizontal u, and it will be equal to, try to recall the basics of trigonometry that we have seen in the previous chapter. So horizontal component, that is x directional component of this u, will be u, cos alpha. The vertical component will be u sin alpha. So this becomes u cos of alpha. This becomes u sin of alpha. Check the signs. Here range is horizontally towards positive x direction, so I should write it as plus r only. U cos alpha, u sin alpha. U cos alpha is rightward, u sin alpha is upward, which are both in the positive direction. So I did not put a negative sign anywhere. Now final velocity in the horizontal direction, that is x direction, final velocity, that is when the ball is here, almost just about to touch the floor. Now that either you can intuitively write or you can keep it as unknown and then you can find it. So intuitively, how can you do that? Since in the horizontal direction there is no acceleration, the only acceleration that is in the vertical direction. Horizontal, no acceleration. What is acceleration? Defined as change in the velocity, but there is no acceleration, so there is no change in the velocity. If there is no change in the velocity, your initial velocity and final velocity have to be the same, and that is why v in horizontal direction has to be u cos alpha. In fact, at any location, if you see the velocity of the horizontally moving shadow, it's going to be the same. It's going to be u cos alpha at any location. But you could have intuitively find it out, because there are going to be 4 known parameters in here, and that is why you could have kept it as unknown and then found it out by using one of the kinematic equations. So what is horizontal acceleration? I have reiterated it many times. It is going to be 0 meters per second square. How much is the time for horizontal motion of the shadow? It is going to be time of flight that we need to find. So this is an unknown, a question mark in there. So let me put it in probably in red color. So this is a question mark. This is a question mark, right? And what are the things that you, yeah, it's a question mark. So what are the things that you know? You know u cos alpha, because you know u, you know alpha. Those are the known things. You have to give with what velocity you are throwing the ball and at what angle you are throwing the ball, because unless you know that, how can you find how far will it go, how high will it rise, and what is the time that it will take. So you at least should know what is the velocity with which you are throwing and what is the angle with which you are throwing. So this is known, this is known, acceleration is also known. Now coming to y side, you have s is equal to 0 because there is no y vertical change in position. U is equal to u sin alpha. V is equal to, now final velocity in vertical direction. That means what is initial velocity in the vertical direction? It is u sin alpha. Finally, when the ball is about to hit in here, what will be its vertical component of the velocity? The horizontal component is already known, it is u cos alpha. What will be its vertical component? Intuitively, you can say that it is going to be u sin alpha, but in downward direction, because this is u. So its two components will be u sin alpha and u cos alpha. Now intuitively you can say that it is going to be u sin alpha, but if you don't like to do it intuitively, you keep it as unknown. Okay, so we don't know it. What is acceleration in vertical direction? We have already seen it is going to be minus g meters per second square. And what is the time taken? It is capital T, that is the time of flight. Now let us solve this both the sides. The time is the common linking parameter between the two. We will try to solve them. So I'll just remove this figure and then solve those two equations. So let us first analyze both the sides. This side we have 3 things known, but they are not going to be of much use, because you know that u and v both are the same, and that is the consequence of having acceleration 0. So that side is not going to help me much. Whereas on this side I have u sin alpha as your velocity, s displacement is 0 is known, and acceleration is also known. So these are the 3 things that I really know, and that is why let me first solve for y side. Okay, so which equation will help me? Can you judge? S, u and a, these are the 3 things that you have. So which equation will help me? Probably v square is equal to u square plus 2as, or maybe s is equal to ut plus half at square. So let me go with s is equal to ut plus half at square. So ut plus half at square. Remember that this is only in y motion direction. Okay, so s, how much is s? It is 0. What is u? It is u sin of alpha into t. How much is time? Capital T. It is unknown. So this equation is in fact going to give me that time. plus half into acceleration. How much is acceleration? It is minus g. So let me put here minus g into capital T square, because small time is capital T. Okay. Now since this part is negative, let me bring it on this side so that it will become positive. Simultaneously, I am going to cut one of the t's, right? So what am I left with? I am left with u sine of alpha is equal to half into g into t. It has turned into a positive sign. Also, I have cut one of the t. Okay. Now that gives me capital T, that is the time of flight, that is one of the three things that we wanted. We wanted R, H and T. So it gives me T is equal to, this 2 will go on the other side. So 2u sine alpha divided by G. Okay. So that is the total time of flight. Let us make a box because this is going to be an important equation. Now this tells me that if you give me just the initial velocity with which you are throwing and the angle at which you are throwing, that is basically the initial parameters, just by standing here before the ball lands on the floor once again, I can tell you how much time it is going to take. I don't even need to measure how much time it takes. You just tell me, I'll just look at you, at what velocity are you throwing and at what angle are you throwing. The only initial parameters. After that, I won't even look at you. I'll just calculate the time and I'll say, okay, so after 5 seconds, it's going to fall on the floor once again. So it's 3, 4, 5. And at that instant, it should hit the floor. That is the power of physics that we have. So that gives me my first parameter, time. So it's known now. Now let me write it here so that we can use it somewhere else. So it's 2u sine alpha by g. I'll write it here as well. It is 2u sine alpha by g. It's interesting to see, this also gives me time for the vertical motion of the ball. You remember in the first chapter we have seen one dimensional motion where you throw an object up and then it lands back into your hands. Now what is the angle at which you are throwing it up? When you are throwing it up, the angle of the initial velocity with the horizontal, the angle is 90 degree, right? So put alpha as 90 degree here. Refer our table of trigonometric functions. What is the value of sine of 90 degree? It is 1. So this will vanish. It is 1. What are we left with? 2u by g. Try to cross check with the answer that we have got earlier. It is going to be 2u by g. The total time that it takes to come back to your hands. That numerical I am talking about. Now let us analyze the second parameter. So we have our time now. What are we left with? We know we need our range and we need our height. So height has nowhere come in picture. Can you tell me the reason why it has not come in picture? Because my initial point was in here and my final point was in here. So how will the height come in picture? If I take initial point in here and final point in here, right? That means here. So this is my initial and this is my final. Then only the height, that is in vertical motion, the height will come in picture. Since I am considering this as initial and this as final, there is no question of height because it's coming somewhere midway. So that couldn't come anywhere in picture. So that is one thing that is left. So let us try to find the next unknown in our series, that is R. So range, that is the total horizontal distance. Now for horizontal distance, you only need to analyze this side, x motion, right? So which equation can I put now? This is one known thing, this is another known thing, this is another known thing, right? So I can write probably s is equal to ut plus half at square. Now acceleration in x motion, so this is in x. Acceleration is going to be 0, so this term you need not worry about it, even though it is time square, but it's going to vanish because I'm going to put acceleration as 0. So what do I get it as? S is range, which is r, is equal to u, which is u cos alpha, horizontal velocity, into t, which is time, which we got in the previous step. So how much is the time? 2u sine alpha divided by g. Now what does it give me? I'll club together u and u. There is an into sign in here. So u into u. So how much is it? U square. There is 2 also. So 2u square. There is sine alpha, cos alpha. So it's going to be sine alpha, cos alpha divided by g. Now you can either remember it as is, or when you come across trigonometric identities in your mathematics portion, you will see that 2 sine alpha cos alpha, these three terms, 2 sine alpha cos alpha, we can club them together to get sine 2 alpha, that is sine of 2 times alpha. Okay, there is a trigonometry identity that says this, so we can club it together just so that it becomes concise to remember. It becomes u square sine 2 alpha divided by g. So you can either use this formula or you can use this formula. It's going to give you the same answer for range. Okay, now for next portion we are going to change our final point, because as I have said, our height we cannot find by taking initial point at the beginning of the motion and final point at the end of the motion. The height nowhere comes in picture. So we'll have to change our final point and analyze the vertical motion once again, which gives us height. Right, so I'll keep my y motions parameters. X motion parameters are no longer relevant because we have got our r, we have got our t. So I'll just rub them off. I'll have to change my final point. So these things are going to change. Let me redraw the figure in here. So now only half of the motion is going to be relevant. So this is my half of that motion and this is the rest of the half which we are not going to consider. What is the vertical? That is y motion's position change. Initial position in y direction is here at 0. So these were your y axis and x axis, right? So what is the vertical position? Where is initial point? Here. What is the final point? Here. What is the vertical change in the position? It is going to be our height, which we want to find. So let me put it here. My vertical position change, that is y motion's position change, is h. Remember, my initial and final point, initial has remained the same, final has changed, and that is why I am changing these parameters. Displacement in vertical direction is the change in the position, which is final position minus initial position, which is height in vertical direction. Now u sine alpha, vertical velocity, initial vertical velocity is still going to be the same, because this was u, this is alpha, and this is going to be u sine alpha, because initial point has not changed. So a parameter that is linked to the initial point will not change. Final velocity, now that is going to be a surprise, so I will tell you that. Acceleration, throughout the motion the acceleration was minus g. So even if we consider half of the part, it's going to be minus g. Now time, for the entire motion the time was capital T. So for half of the motion it is going to be t by 2, but that is intuitively. If you don't agree with me that it is going to be t by 2, we can prove it, but that is not necessary as of now. So let me say that I don't know the time. Let us assume that I don't know the time, but it's going to be half of the original time. In fact, you can take it as a task. Once we know three things, you can find out the right equation that gives you the time, and you will find that it will be u sine alpha by g, which is half of 2u sine alpha by g. So that's your task. Okay. Now what about v? That is the final velocity. Where is my final point? Here. Which motion am I analyzing? Y or x motion? I am analyzing y motion. So what is the y velocity when the ball is at this point? Now remember, when the ball travels, its velocity goes something like this, and then this, and then this, and then finally at this point it will be perfectly horizontal, and that is why it will no longer rise in vertical direction. Since the velocity becomes horizontal at the topmost point, it no longer will rise up. In fact, it will start going down now. So at the maximum point, its velocity vertical direction is going to be 0, and that is why we will put 0 in here for this half part of the motion. It's going to be 0. So now I know this 0, I know u sine alpha, I know g. What do I not know? I don't know h, I don't know t. It's going to be t by 2, but you can prove it by taking appropriate equation, because we know we need only three things. They are with us. We can now solve this equation. So I will solve something that is related to s only. Time is your job. So let me write s is equal to ut plus half at square. Will this equation give me my s? No, because we don't know time. So I'll have to find some equation which involves all the quantities but does not involve time. So which is that equation? Yes, right, it is v square is equal to u square plus 2as. Now what is my v? Final velocity, it is 0. What is my initial velocity? It is u square sine square alpha plus 2 into what is my acceleration in vertical direction? It is minus g into s. So that is h, which is an unknown that we need to find out. Let me bring this negative part on this side, it will become positive. So I get 2gh is equal to u square sine square alpha. See, sine square alpha is sine alpha into sine alpha. Sine alpha square, that is sine square. Now h becomes u square sine square alpha divided by 2g. Let us make a box. This is the third important equation that you need. So h range was u square sine 2 alpha divided by g, and time was 2u sine alpha divided by g. So these are the three important things that totally categorize your projectile motion. So if somebody stands in here and throws a ball, then just by knowing the initial velocity and the angle at which it is thrown, you can tell him in how much time it will fall back on the floor, how far it will reach, and how high it will rise. Another interesting that I already told you is, in anywhere you put the value of alpha as 90 degree, it will give you all these parameters necessary for vertical motion also. Now tell me intuitively, for vertical motion, what should be the value of the range? Since the motion is going to be vertical, your horizontal motion will be 0, and that is why range should be 0, and the same answer should come from this formula also. So your range should be 0 if I put alpha is equal to 90 degree. Let us see if it works out that way. So I'll put my alpha as 90 degree. For doing that, you should know, because it's going to be 2 alpha. So 2 into 90 degree, which is 180 degree. I have given you trigonometric table only up to 90 degree, right? And that is why you won't be able to do it by this formula. But remember, we had one more formula for this, which was a bit simplified than this. So let me write that formula, because you don't know what is sine of 180 degree. Though I know that, but it's not in a scope as of now. So what was the earlier formula? It was 2u square sine alpha cos alpha divided by g. Just refer back when we derived it. So it was this formula. Now plug in alpha is equal to 90 degree. What will you get? Sine alpha, how much is it? Sine of 90 degree 1. Cos alpha, cos of 90 degree. Refer our table of trigonometric functions. You will see that cos of 90 degree is 0, and that is why it will make this entire thing as 0 if I put alpha is equal to 90 degree. And that is why when you throw it up, the equations still apply. When you throw it in inclined, the equations still apply. Okay.